Hello, my fearless minions. Lecture 4 in the organic unit. Today we deal with isomers. And here we go with another I word. This is our third one, right? We have ions, isotopes, and now isomers. So today's video is going to be just based on this word isomer. What does it mean and how do I figure out what they are? Basically, it's the same number of carbons and hydrogens in a different form. So as long as it's the same number that I start with and I end with, basically move double bonds around, move triple bonds around, I will be an isomer. And so that's what we're going to study today. So exactly what I just said. It has to have specifically the same molecular formula, but different structural formulas. So when I look at this, examples, methane, ethane, and propane do not have any isomers. This is true. I can't really rearrange this in any way. I can't put this carbon anywhere else and make it look different. I really can't create a double bond or a triple bond here because it's saturated and there's just not going to be any way to do anything. Butane is the first molecule to have isomers. The larger the molecule, the more carbon atoms, the more isomers I can make, okay? There are only 3 ways to make an isomer. Remember, I have to have the same not structural formula, but chemical formula, or it's not going to work. I can either make a branch, I can move a branch. Very good. I can change that number in the beginning. Or I can move a multiple bond. Again, making the the number in the beginning change. So example 1, I have pentane isomers, break off a terminal carbon and put it in a non-terminal position. Terminal means end. And so for those of you that are listening and not just muting me, you'll understand now that terminal means end. So this is regular pentane, but to make 2-methyl-butane, what I do is I take this carbon off, okay, and that's going to leave me with 4. 1, 2, 3, 4. And if I slide it over to here and bring the H around to there, I will end up with this. Notice I have the same number of carbons and hydrogens. I have 1, 2, 3, 4, 5 carbons. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. Still C5H12. Okay. In the third case, I took 2 terminal carbons off and put them both on the middle, and I still have 1, 2, 3, 4, 5 carbons and 12 hydrogens. So because I have the same number of carbons and hydrogens, that's what we call an isomer. Notice you can only make branches on the non-terminal carbons. It doesn't make any sense if I were to, let me change colors and erase a little bit, just so we can see. If I were to take this carbon, cut it off, and put it over onto this carbon, it would be the exact same thing. So that's why I can't put the branches on the non-end carbons. Remember, terminal means end. If you needed a carrot, that would be one. So example 2, pentene isomers either break off a terminal carbon and put it on the non-terminal position or move the double bond around. So let's draw pentene first. Pent, ready, is 5. 1, 2, 3, 4, 5. On my first carbon, I'm going to have a double bond. Fill in my bonds here. My first carbon has 2 bonds, so it needs 2 more. The second carbon has 3 bonds, so it only needs 1. The third carbon needs 2 more to have 4 full bonds. The fourth carbon needs 2, and the fifth carbon needs 3. Okay, so it says either break off a terminal carbon and put it on the non-terminal or move the double bond. Let's start by moving the double bond because that's the easiest thing to do. So C, 1 single bond and then the double bond. Still have 5 carbons, 1, 2, 3, 4, 5, beautiful. Then let me fill in my hydrogens. I need 3 bonds to this carbon. The second carbon now has 3, so it only needs 1. The third carbon now has 3, so it only needs 1. I should have drawn it up so they're opposite. That's okay. I need 2 on the fourth and 3 on the third. Okay, well, let's move the double bond one more time. I got C. Oh, by the way, don't write this down because I'm going to prove to you it's wrong. Let me heads up on that. Ready? Spoiler alert. C, C, move it to this carbon, right? And fill in my hydrogens. Well, the reason why this one's going to be wrong is, if I count backwards, 1, 2, I just made 1, 2, I just made the same molecule, it's just rotated. I need to flip this thing like that, and then I'll have this again. So I've moved the double bonds as much as I can. So that's why I spoiler alert, so you didn't write it there. If you're not listening to me and you're muted me, you will need to draw your own little box down here to come up with this last isomer, because that one was wrong. Okay, so let me move this carbon. I'm going to have C, double bond C, C, C. Let me take this carbon and move it here. That would be different. This carbon needs 2 hydrogens. Second carbon is all good. This carbon needs 2 hydrogens. Fourth carbon needs 3. To have my 4 bonds. Notice I draw my bonds first because that's what I'm counting, not hydrogens. Now that thing is definitely different. I could, oh wait, I didn't finish my methyl. Thank you for noticing. I could also put the carbon here, the methyl, right? So I could go C, double bond, C, 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 but instead let me put the methyl on the third carbon instead of the second carbon. Okay, Mr. Milks, if you must. It's the truth though, I could do it. This would need 1, finish off my methyl. He needs 1, he needs 3. Beautiful. And now he's different, yet the only other thing now is to do it starting with this double bond moved is the only other way I can change things around. Because if I move this carbon over here, it's the same thing. I can't move this carbon to the top because that's the same thing also. It's just rotated in a different direction, if you will, like a canoe tipping over rotates in the in the river. So let me draw it all over again now with this more of a configuration. C, C, 1, 2, C, C, right? Good. And then let me put the methyl right here. And it really doesn't matter which side I put it on, because if I rotate it, it's the same thing. So I can only draw this one way. This one needs 3 H's. This carbon, second carbon has 4 bonds. Let me finish my methyl. Third carbon has 3, so I need 1. Should have drawn it on top so it wasn't near the methyl. That's okay. Defying my instincts. I'm not really going to harp on you about that stuff. And there's another way to draw pentene as an isomer. So we're getting the hang of what these whole isomer things are. I really did take my time and do it out. Benzene, here's 2 different ways to write benzene. Aromatic hydrocarbons contain 1 or more benzene rings or closed chains. So benzene, when I see this ene, there's a double bond. And this is what it looks like. They alternate because I can't have double bonds on either side or I wouldn't have any hydrogens on there. Okay. Now, current events of 2006 really isn't current events, Mr. Milks. Trimethyloxy benzene, 1, 2, 3, yeah. We're not going there. We're not going there. Anyways, practice packet. Now I can do page 11 and 12 because I know a little bit about isomers. We need a little bit of more practice. Basically, remember, I change the structure and the name, but I don't change the number of carbons or hydrogens, and I have the exact same formula. So we now know a little bit about isomers, and I was hoping to be a little shorter, but it's not. Sorry about that.